Hello everyone, today we will discuss recurrent neural network RNN. So let's start. First of all, I want to clarify that most of the neural networks at each data point they work independently, but RNN is special in the terms that it stores the memory, hidden state. So what it does, look at the diagram on the right side. For example, if we want to find H1, it will take the previous hidden state from the memory and using the data X1, it will define H1, the hidden state first. And it will be used to predict Y1, the target variable. Similarly, if you want to find H2, the second hidden state, will be defined from the previous hidden state H1. In a short time, I'll show you the equation for finding the hidden state. But the bottom line is any hidden state can be found using the formula from the previous hidden state and the data point. So once you find the hidden state for that t, then you can use that hidden state to predict y variable. So now I'm going to show you the equations. These are the core equations because we were talking about the hidden state and the predicted variable y. So how we find it, first of all, hidden state, how we find tangent hyperbolic into weight time x, the data point, plus weight time previous hidden state plus bias, right? So this way, for each x value, you can define the hidden state. And each time, once you find, so if you want to find a hidden state, you need the x value for that state, t, and you need the previous hidden state, ht minus 1, right? So that hidden state will be used to predict the target variable yt using the equation weight times hidden state plus bias, right? So now I wanted to show you with some numbers. Suppose we initialize all the weights and biases that we need for the above equations for finding the hidden state and the predicted variable y. So all these weights and biases that we seen in the previous page, we can initialize them. Of course, we have to start with some numbers. At the beginning, we don't know anything about the weights. So suppose you can use random number generator within the range and find weights and biases for these equations, right? We can also initialize the initial state as 0 to start with, right? Because at the beginning we need some numbers for these weight, biases, initial hidden state. So you can use random number generator. But the RNN model will update these numbers. That's the job of the model, to update these biases, weights. So when the model will be trained, all these biases, weights that we initialized will get changed and optimized for minimum error. I'll discuss the error as well very shortly. For example, the x values are 1, 0.5 and -1. So let's apply these equations. First of all, for the hidden state, that's the same equation that we have seen. So you can see the parameter first is wait time x. So x value would be 1, and wait time h naught, which is 0, and plug in all these numbers that we initialized in the previous page to get h1 equals 0.537. So the main thing is to look at the x value, and h naught is the previous hidden state. If you're finding h1, h naught would be the previous hidden state. Once you found the hidden state, 0.537, you can find using the same equation that I've shown you on the previous page for the target variable, and you'll get 0.537. When you find y value, predicted y value, you'll use the hidden state here, as you can see in the equation, right? First find the hidden state. Using the hidden state, you can find the predicted value, predicted y value. Once you find the predicted y value, you can find the error from there. For example, mean squared error. And the main theme is the error would be the difference between the actual value in the data for y and predicted value of y that we found here, right? So for each observation, you repeat the same process. h2 you can find using the next data point x2 and using h1 that you found in the previous step, 0.537, and you'll end up with the new h value, and use this h value to predict the y2, and then from there y2 predicted value, you can find the error as well. So each time you repeat the same process and find the error. Once you've gone through all this process, all the data points done, then you can find the average error. And what the RNN will do, it will use the backpropagation, and using the optimizer, for example, Adam optimizer, it will update the weights and go back and forth until each time it will calculate error, go back propagation, update the weights and biases until the error is minimum, and then the model is ready and trained. And those optimized weights and biases will be used to predict new data using RNN. I think that's enough for today. Thank you very much. See you next time.